So, I was discussing the energy and spectra of vibrating rotator. Okay. So, we have seen that for Born-Oppenheimer approximation, I think this Oppenheimer So, according to Born-Oppenheimer approximation, this total energy for rotation and vibration, that means vibrating rotator. So, that will be just summation of the individual energy of a rotator plus individual energy of a vibrator. Okay. Because this energy is del Ej or del Ev. So, this energy in the order of 10 to the power minus 1 centimeter inverse, and it is in the 10 to the power 3 centimeter inverse. Okay. So, their separation is quite high. So, there will not be any interaction energy term for rotation of the molecule and the vibration of the molecule. So, just this total energy will be simply the summation of the individual energy, and that we have written that this is B j plus 1 minus d j, I think that is j cube j plus 1 cube. I think this I will erase it. Okay. So, that was the rotational energy, and plus the vibration energy I can write V plus half omega E bar minus I think minus Xc V plus half omega E half square omega E bar. Okay. So, that was the energy. So, here I have drawn the energy levels and shown the transition. So, here basically when I was drawing, so here simply this term we neglected in this case, because this D value is very D value and B value. D is in the order of I think it is order of 10 to the power minus 3 centimeter inverse, this D value in the order of 10 to the minus 3 inverse, and whereas B value is around 10 to the power 1 centimeter inverse, means 10 centimeter inverse. Okay. So, compared to B value, compared to this term one can neglect, and of course, this anharmonic constant also is very small value, but this will not neglect. we do not neglect, because then we will lose this selection rule del V equal to plus minus 1 plus minus 2 plus minus 3. So, this selection rule was valid because of anharmonicity. Okay. If anharmonicity, we neglect this anharmonicity, then one cannot, only one has to use selection rule del E equal to plus minus 1. So, that is why this will not, although this Xc anharmonicity constant term is small, but still we will keep this term, because then only one can use these selection rules. So, this energy is for vibrating rotator. So, this energy expression one can write this is the energy expression. Okay. And for this, now here one thing I would like to tell you that yes. So, I think if I consider this energy level and okay. So, I think this I can write here, and later on it may be useful for me del. So, this energy J V equal to B J plus 1, okay, minus, sorry, here I have I should not delete that one. So, that was omega E bar plus omega E bar, I think it was 1 minus X E V plus half, okay, then this and then V plus half. So, this is the energy expression, and if I draw this here, now I do not need this one. So, this I am repeating this discussion because this very important, and real system, most of the molecules basically it shows this behavior. Okay. It is vibrating rotator, it is so that model is applicable, appropriate for most of the molecules. So, pure vibration, pure rotation, some of the molecule shows, but most of the molecule shows this vibrating rotator. And if I draw the energy levels, so I have, so this for vibration, okay, this is the energy level for vibration, this is the energy level. So, this is the, say, V equal to 0, and then this is the energy level for vibration energy level V equal to 1. Similarly, V equal to 2, V equal to 3 one can draw. Now, this energy separation is, as I told, this is a 10 to the power in the range of 10 to the power 3 centimeter inverse, whereas here now for V equal to 0, V equal to 0, whatever the value, that is this value. Now, if I put different value of J, different value of J starting from J equal to 0, 1, 2, 3, J equal to 0, 1, 2, 3. So, J equal to 0 it will not contribute. So, the same value. So, it is J equal to 0 also it is the same line, you know. So, that is J equal to 0, and then J equal to 1. So, it is you will get J equal to 1 okay, then j equal to 2, okay, j equal to 3. Okay. So, it is not in scale, just I have drawn, because separation will not be that much, it is very close to it. Similarly, for v equal to 1, I will get a set of, so this for j equal to 1, j equal to 0. Now, I will get 1, 2, then 3. Okay. So, this is a j value. Okay. Now, transition is so this transition is not allowed, basically j equal to 0 to j equal to 0, because del j equal to 0 selection rule, del j equal to plus minus 1. Okay. Del j equal to 0 is not allowed. Similarly, del v equal to plus minus 1, plus minus 2, etc. Okay. So, this transition j equal to 0 to j equal to 0 is not allowed, okay, in case of vibrating rotator, because both selection rule has to be satisfied. So, this line, spectral lines will be, original spectral lines will be missing, okay. But instead of, if it is only vibration, okay. So, I will get the spectral lines, okay. Because this del v equal to 1, okay. So, I will get the spectral lines. So, if it is pure vibration of the molecule, so that is why we tell. So, and whereas here you are seeing this transition, in case of vibrating rotator, this transition is not allowed. So, that spectral lines will be missing. Okay. So, only we will get, when we will get, only when it is purely vibrational. Okay. When it is vibrational rotating spectra, in that case it will be missing, but corresponding we will get, in place of it we will get a branch of lines. So, from where these branch of lines are coming, so that was I was trying to explain. So, this transition is allowed 0 to for del j equal to minus 1. So, starting from 1 to 0, okay, 1 to 0. So, here j equal to 1, here j equal to 0. So, del j equal to minus 1, for del j equal to minus 1, that is allowed. So, del j equal to minus 1, this, then this transition, then this transition will be allowed. Okay. So, I will get this spectral lines, right. Similarly, for del j equal to plus 1, so it started from 0. So, this j equal to 0 to j equal to plus 1. Okay. So, this transition will be allowed. So, this transition is not allowed, j equal to 0 to j equal to 1. This transition is not allowed, because then del v will be 0. Okay. Then del v equal to 0. Okay. So, here although del j equal to plus 1, 0 to 1, rotationally it is allowed, but for vibration is not allowing, because del v, in this case v equal to 0 to v equal to 0 this transition del V equal to 0, that is not allowed. Okay. So, in this case this transition is not allowed, but this transition is allowed from j equal to 0 to other vibrational level j equal to 1, del j is plus 1. Similarly, in this case del j equal to 1 to j equal to 2, j equal to 2 to j equal to 3, okay, del j plus 1. So, these lines, spectral lines, we will see. And this separation, you see this separation, this spectrals. So, here this all the energy, whatever separation we are getting, that is the separation of the this separation is equal to the separation of rotational energy levels, you know. So, rotational energy levels, so they are very closely spaced. Okay. This original energy, so this original energy is this, it is a 10 to the power 3 centimeter inverse in that order. Now, so this one is slightly lower than this 10 to the power 3 centimeter inverse, and these are slightly more lower side, slightly higher side. So, these spectral lines, these spectral lines is basically as if you are getting these spectral lines, you are getting now very closely spaced. This is missing basically, this is missing, very closely spaced many spectral lines. So, instead of one you are getting many. So, you are getting basically this, we are telling instead of lines you will get a band. Okay. So, here I told you that when I will get only one line and when I will get this band. So, only one line will get when it is purely vibrational. Okay. In case of vibrating rotator, this transition is not allowed, then it will be j equal to 0 to j equal to 0. So, del j equal to 0, when del j equal to 0, this then if it is allowed, then it will be purely vibrational energy. Okay, vibrational energy. Okay. So, that is why we tell when del j equal to 0, del V is not equal to 0, it is purely vibrational, it is purely vibrational. Okay. Similarly, as I told that this j equal to 0 to j equal to 1, it is allowed, but del V equal to 0, that is not allowed. Okay. So, when we will see this kind of transition, del V equal to 0, but del J is not equal to 0. Okay. When del V equal to 0, if it is allowed, but del J is not equal to 0. Okay. Del J equal to plus minus 1, del V equal to 0. So, that means this transition is allowed. So, it will be purely rotational. Okay. So, when this condition will be satisfied, then it will be purely rotational. Okay. Purely rotational. When this condition will satisfy it simultaneously, then it will be vibrating rotational, Okay. So, now this as I told, this branch basically you will see the branch. So, higher side and lower side, Okay. So, this is called this is P bunch, this is called P bunch, okay, and this higher wave number side, this is called R bunch, okay, and middle it is not there, but if anything is there, then it is called Q branch, Q line, okay. So, this for del j equal to -1 this side, and this del j equal to +1, okay. So, basically for different j value, because del j equal to -1, del j equal to +1, this is valid, yeah. So, if there is a violation of this, for any case, if it is violation of this del j equal to 0, this it is q, del j equal to 0, it is q, okay. And if del j equal to -2, so then it is extended, okay. So, then it is called O branch. If del j equal to +2, then it is called S branch, okay. These are the, so in our case it is this, for vibrating rotation it is this is the situation in vibrating rotation, this is the situation, okay. You will get basically P bunch and Q bunch, sorry, R bunch, and yeah, there will be no branch for Q, but it is in general nomenclature for del j equal to 1. So, Q branch, then -1 P bunch, -2 O branch, +1 P bunch, +2 S branch. So, these are the, this is the nomenclature, okay. So, I think, yeah. So, whether it is purely rotational, whether it is purely vibrational, or it is vibrating rotational, so one can seeing the spectral lines, studying the microwave spectra, and infrared spectra. So, one can tell which kind of molecule it is, okay, whether these molecules have only rotational or only vibrational, or it has both of rotational and vibrational, okay. So, seeing the nature of the spectra, one can conclude about the molecules, and yeah, different information about the molecules from the from studying the microwave spectroscopy or and the infrared spectroscopy. One can get lot of information about the molecules, okay. So, this I think in simpler way, that's this molecular physics, so far whatever I taught this in simpler way, simple cases I have chosen and trying to, these are basic study, basic things, but there are some complicated, for as I told this, we are considering only diatomic linear molecule, but for other molecule, polyatomic and nonlinear molecule, it's slightly complicated, and that's what it is. I think it is not necessary for undergraduate student. Whatever I am teaching you, that's the basic and requirement for the undergraduate student. other things I think one has to study in higher class. So, I will stop here today. In next class probably I will start this electronic spectra of molecules. Okay. So, thank you for your kind attention.